Like in general, I think people have gotten used to listening to the word climate in the context of climate change. So always as being part of a problem. But in fact, the climate and the changing climate is the very condition of living on a planet, is that with an atmosphere, is that you have different climate zones that get different exposure to sunlight, that have different temperatures, different levels of precipitation or aridness. So in that sense, it's really a given. And I think one of the causes of the current climate change in the form of global warming comes from the built environment, and it comes from the fact that let's say with the advent of modernism and building services, modern building services, you know, air conditioning and central heating that made you independent of the thickness of the walls or the orientation, with the advent of omnipresence of electric lights made you independent of daylight, and the presence of windows so you could make deeper floor plans. And finally, let's say mechanical ventilation made you independent of opening the windows or having a natural airflow, because you could just pump fresh air into the building. As a result, buildings, the architecture that used to be a cleverly empirically evolved response to the local climate suddenly became a universal style of modernism that looked the same everywhere. So it just became like a boring box with a gas guzzling machine room that would pump quality light air into it to make it inhabitable. So I think one of the things we're looking at is trying to see if we can return the architecture to be actually responding to the climate. One of my sort of great inspirations is Bernard Rudowski, who did the exhibition Architecture Without Architects, where he saw how you know, all over the world people had found ways empirically over centuries to use the locally available materials to respond to the local climate in a way that would make the buildings as nicely inhabitable as possible, including elements of natural ventilation or thermal insulation. And he called it architecture without architects. And I think what we are interested on that account is what you could call engineering without engines. How do you use sophisticated engineering to make the building less dependent on machinery? To use the fact that we can calculate and simulate and model the performance of a building to make it less necessary to use active machinery to make it inhabitable once it's built. You know, it's in a way sort of discovering or rediscovering what, you know, like Chandigarh. I recently visited Chandigarh by Le Corbusier, and his obsession with brise soleil, and brise soleil being differently designed depending on which way you would be oriented. He actually made this like small pavilions called the Tower of the Sun, where you had a cube, and it was facing in 4 different directions, and each direction it would have different brise soleil, because depending on if the sun comes from the you know, if you're oriented to the north, the east, the west, or the south, then the incoming sun rays or the absence of sun rays or the angle of the sun rays is going to be different. So therefore the architectural response should be different. I think one of the problems with Le Corbusier is that he ended up over-regulating so much for sunlight that when you walk around in Chandigarh, it's actually pitch dark in most of the places. But essentially this sort of idea of trying to relearn the texture of the skin, the distribution of mass, the creation of outdoor spaces in certain areas and not in certain other areas, is in a way sort of rediscovering some of the care that empirically goes into layouting a village or a town, because people live there. You know, they start by building a building, then they figure out that they spend more time on this side of the building than on this side of this building, or maybe on this side of the building the windows are simply too big, so they make them smaller. On this side, if they open up, they can actually get the breeze in. So this kind of knowledge that accumulates over time when people inhabit a certain territory, it's the kind of knowledge that we as architects have to try to put into the design process rather than in the afterlife, so that in the design process we test and try as many of these aspects as possible before we built. Sustainability was always spoken in the context of stopping growth, or like giving up some of the quality of life that we have now, because necessarily, if things are too convenient, maybe they were like too energy intensive or unsustainable. And I think that's just like a hard selling point, because people might sit in a conference and say, yeah, we have to, this and that, but then they would still take their car and they would still go home and make it nice and warm or nice and cool, depending on what climate they were living in. But of course, like, the right answer is to make the Tesla Model S, which is the best car ever produced. It's the safest car ever produced. It's accelerating faster than any sports car, and still it runs only on batteries. So it's not only more sustainable, it's also more enjoyable. And on that note, like, I think one of the things that we're seeing is that clean technology comes with positive social side effects. Our first project we ever built was the Copenhagen Harbor Bath that extends the life of the city into the water. So it means that it's not only more, it's not only good for the fish that the water in the port is clean. It's actually so nice that you don't have to sit in your car for hours to get to the beach. You can jump into the port in the middle of the city. So suddenly, sustainability actually becomes the more fun, the more enjoyable alternative to what we know. Maybe just to stay in Denmark for 2 seconds. I think one of our strongest sort of applications of hedonistic sustainability is, for instance, the power plant we're building in Copenhagen, where the technology is so clean that you have only steam and a little bit of CO2 coming out of the chimney, but no toxins, which is something that is invisible. And we came up with the idea that if we would turn the entire park of the power plant into a gigantic ski slope, then not only would it be amazing for the Copenhageners that they can now have alpine skiing, because we don't have any hills, but we do get snow in the winter, but also it would be great for the owner of the power plant, because he wouldn't have to, or she wouldn't have to, make expensive ad campaigns or print pamphlets where people could read that her technology was clean. Because when you go and see it, it's like sort of, wow, what is this? This is like a completely different kind of power plant. So I think that idea is something we're trying to pursue as widely as possible right now, since I think with advances in technology, there'll be a lot of interesting hybrids possible today and in the future that would have been impossible in the past. Because like 50 years ago, a power plant and a waste management facility would be one thing that you would really want to stay away from. Now you actually have fresh mountain air on top of it and you can ski on it. What we're talking about is what you could call Vernacular 2.0. That it's not vernacular in the sense of repeating what's already there, but it's vernacular in the sense that it is adapted to the surroundings, the climate, the culture. And of course, when we get new tools that allows us to simulate and calculate and predict and rapidly test and speed up evolution in theory by having parametric design models where we can test the feedback of certain forms, we can actually go way beyond the vernacular that already exists, that we inherit, and create something for new life forms and new lifestyles with available materials, but still using the same idea of responding to the local climate. So I'm actually not talking about nostalgia, I'm just saying learning what there is to learn, and then in a similar way make sure that whatever we do is adapted to the environment. And because we can now predict certain things with computer simulation and physical modeling, we don't have to build it first before we understand it. We can actually test it and learn from it even in the design process. I think I always, my old Danish teacher in high school, she told me that if you don't speak clearly, it's because you don't think clearly, which I think is quite true actually. And I think quite often I found myself, because I've been teaching quite a bit and of course having an office with a lot of colleagues, I often find myself that if you don't have the time to draw it yourself, you have to be able to communicate very clearly, not what someone else should draw, because then it's probably going to be faster to do it yourself, like, up, over, down, right, circle, curve, that wouldn't work. But to try to put into words what are the criteria, what are the key criteria, what is it that we're trying to respond to, what is the knowledge we're trying to harness, and what are the qualities we're trying to create. And in that sense, communicating and clarifying becomes a form of empowerment, that you empower the team and the consultants with the knowledge of what this project is all about. And I think people that are interested in ideas like Wodowski and Le Corbusier, they had an impact because they were very good, sometimes too dogmatically, and each time you put things into formula. And I think Le Corbusier was a very smart teacher, but he had a tendency to teach solutions rather than principles, or like he had a tendency to provide the answers rather than to enabling people to ask the right questions. And I think that's why Le Corbusier had such a great impact, but also often a quite negative impact, because what got reproduced was actually the solutions rather than the methodology. And that's why it became a style rather than a movement. I'm always very careful about providing the answers, and what I really like to do is try to find ways of pointing towards the right questions, and then showing how things relate, the causalities, that if you do this, then this might happen. If you do this, then this might happen. So in each and every case, you have to choose your weapons. That's also why earlier today I was asked, some of our projects are very curvilinear, some of the projects are very sort of faceted, some of them are like very sort of straightforward. What kind of architect are we? And I think each and every case deserves that first you care, you stop and you find out what are the big questions here, what are the problems, what are the potentials, and then you try to see what answers could actually fit to this unique set of questions. So I think it's important to have a discourse, and I think the architects that have been good at putting things forward have definitely enabled conversation, and then they've provided vocabulary to populate our conversations. But it's important that those statements are not taken as final answers, but more like evidence of a certain rigor of thinking.